Today I'm going to talk about some strategies you can use when executing Lesson 6B, Rewriting Quadratic Expressions in Factored Form Part 1, with the focus question of how can we rewrite an expression in factored form. Before completing this lesson, students should have worked a great deal with taking an expression in factored form and rewriting it into standard form using diagrams, box method, area models. And you see that happening in the beginning of this lesson. Students are reintroduced to a diagram applying the distributive property, and they are also asked to go ahead and use the diagram to rewrite this expression. So they're given that opportunity, and then again, they're given a bunch of diagrams and expressions, and they're using the diagrams to show how these expressions are equivalent. So this lesson I created this lesson on Desmos as a way to facilitate the conversation and give students the opportunity to show their work. And so the launch is in here, and the next few slides are in here just showing how they can use diagrams to show the expressions are equivalent. And what I'm going to do in this video is kind of talk through how it might look for students to work on the actual meat of the lesson, which is when you get to right here, where students are asked to take expressions in standard form and write them in factored form. And this is the first time they're most likely going to really be doing this. And so I'm going to show you, so in this Desmos lesson, instead of creating it as a table, which there is value in the table because they can see all of them at the same time, but I decided to break it up into individual slides. So if you look, each of those problems on the Google Slides is created into an individual Desmos slide with a box and an answer space. And what I'm going to do is kind of show you how students could work through one of these problems. The main idea here is we're not going to explicitly take a moment and teach them, find two numbers that multiply to 12 and add to 13, make a diamond and set up the diamond method if you've taught that before, any of these very procedural things. We kind of want students to explore and discover on their own how to write this in factored form. Okay. So the way it might look is students already know, okay, I'm going to fill this into the table. So I know x squared goes here. That's the first term. And I know 12 goes here. Okay. And I know that I can put an x here and an x here, right? That's the only option because x times x is x squared. So now I have to figure out what goes here, here, and then what goes here. And so students can use guess and check and play around with this. The first way they might do that is they might say, okay, what are some numbers that can multiply to 12? Well, I can do 3 and 4. Does that work? 3 times x is 3x. 4 times x is 4x. Does that work? No, because that's not 13. And so they could try another pair of numbers, 6 and 2. So 6 times x is 6x, and x times 2 is 2x. 2x plus 6x is 8x. Also doesn't work. So they might say, okay, well, I need to multiply to 12. What else could I try? Well, 12 and 1. And we'll see that that will actually work. So what you can encourage students to do if they're getting stuck is you can encourage them to fill out what they can fill out in the chart to start off. So they can fill out the x squared, the x, and the 12, and the x's and the 12. And then you can ask them, okay, well, can you think of some numbers that could go here? 4 and 3. Try it out. Does it work? No. And then as they do all of these problems at the end, you can kind of have that synthesis conversation. What do you notice? What is a way that you kind of started? How could you be more efficient with this? Well, I know those two numbers have to add up to 13x. 13, when you multiply, they have to combine to be 13. Oh, okay. What do you know about the numbers also? They have to multiply to 12. So what's something that they could do if somebody's really stuck? Just give them the encouragement. Start listing out the factors of 12. What are numbers that I can multiply to 12? What are my possible choices I can put in these boxes? And then we test them out. Another thing students could do is they could try, you might see students do this where they'll try different numbers here. Like they might just be like, all right, well, I know 10 and 3. And so I know x times 10 is 10x. And I know 3 times x is 3x, but do 3 and 10 multiply to 30 now. And this is kind of where students will do this even when you teach it procedurally. They'll focus on the adding to 13 as opposed to the multiplying to 12. And so they can do this and they could keep trying different combinations, here until they get to the multiplying of 12. But it might become really frustrating and they might get stuck. So you might encourage students who are feeling really stuck to be like, why don't you try, instead of plugging these numbers in, why don't you try the different combinations that multiply to 12? Just pushing them in that direction that they don't, because you could do 11 and 11x and 1x, right? And you can have a lot more combinations that add to 13 than the numbers that add to 12. And so students would do this slide and then they would just continue, they're given the chance to refresh their thinking around just the multiplying binomials part, and then they'll be given another one. And as they work through all of these, they should start to be able to draw some conclusions. This one is taking all of that and making it very abstract. But again, allowing them to see, okay, this is x squared. We know that. And we know the last term is mn. And those are going to go in those boxes. And actually, we can see here it's m plus n times x. So we know it's m and n. X, sorry. Right there. Right, and then we have x and x, mx, and nx. Okay, this one's going to be a lot more abstract, and you might have to support students to walk through this. You might put them in breakout rooms to discuss it, to give them that chance to really solidify their understanding that the constant is the multiplication of the two numbers, and the coefficient of the x is the addition of the two numbers. And then they're given the chance to just explain in general, how is factored form related to expanded form? Really restating their thinking there. And then explaining how they can rewrite an expression in factored form using what they learned today. And you can do different closing routines here. The lesson itself gives students a chance to do a compare and connect. You can even do a stronger and clearer to really emphasize and show students how do you rewrite an expression in factored form from standard form. Okay, so in summary, I think the key idea here is we're not teaching kids like, here's how you do this and then giving them a chance to do it. Instead, we're giving them the chance to use the tools they have and the knowledge they have to really explore and think deeper about this concept and discover on their own. You add to the linear term and you multiply. Find two numbers that add to linear term and two numbers that multiply to the constant, to then be able to write it in factored form. And by having this conceptual understanding, it's going to prevent them from making mistakes in the future based on misconceptions.